Alrighty, welcome back everyone to All Things Data. We've got, in this block, we have 2 talks. Before we jump into introducing the next talk, just a reminder that we have a Discord channel. There's some really good conversations about the talks and links to open source packages and things that people are talking about. So jump on in, say hello. We've got people on the online tuning in remotely as well, joining in there. So to kick us off, we've got Alex Ware. And I'm just going to read a little intro here. Alex is a software engineer working for Geoscape Australia and is based in Canberra, Australia. She previously spent several years working as a data engineer in the Australian Public Service. She's a co-organizer of the Canberra Python user group and a co-organizer of the upcoming Django Girls Canberra workshop. She's passionate about big data, clean code, and supporting those with a marginalized experience of gender in tech. So, with that, please, big round of applause for Alex Ware, who's going to be talking about an introduction to PySpark.
Hello, hopefully this microphone is working. Okay, so today I'm going to be giving an introduction to PySpark. In my talk, I'm going to be trying to answer some questions, such as, what actually is PySpark? Can it really solve all of my data problems? And possibly most important, are you sure I can't just use pandas instead? We sort of covered who I am a little bit. So software engineer at Geoscape Australia, working predominantly with geospatial data. The very quick call out for my employer is our claim to fame is GNAF, or the National Address File. But we also do a whole bunch of other geospatial products. I know there's been a bit of discussion about geospatial stuff today. So if you're interested in things like data around property, cadastre, buildings, roads, solar, trees, maybe check us out. Previously in the public service, won't talk about that too much, other than that's where I first started using PySpark. And the workshop has actually happened now. It happened a week ago, and it was a lot of fun. And thank you to Django Girls for supporting us in running that. Okay, the really important disclaimer is that after that slide is I don't talk for any current or former employees. I am here entirely sort of presenting my own opinions. And very importantly, I don't have any major or minor or any links to Apache. I do not speak for them in any way. I am just a hobbyist who played around with the library and got talked into giving a talk at PyCon, as happens to the best of us. Cool. So, as part of this talk, I'm going to be giving a couple of code examples. To do that, I needed some data. And very fortunately, Brisbane City Council actually releases a bunch of information about the library checkouts that have happened over a 3-day period each month. They've been doing this since back in about the start of 2020. So there's a fair bit of data there. And I'm going to use some of that for my presentation. So let's start with pandas. Hopefully, this is all pretty familiar so far. It's very bright up here, so I can't see faces too well. But yeah, basic example. We're going to read in some data from July of this year. We're going to select some columns or fields, and we're going to look at those rows. So far, so good. We can do the same thing with PySpark. Now, you might be looking at this code example and saying, hey, Alex, what's that thing going on with the Spark session? And I'm going to go, that's a great question. I'm not going to answer it yet. But if you look at the 2 lines underneath it, very similar to pandas. So we read in the same data, select the columns, and we're going to show it in a very similar output. Maybe we want to do something a little bit more interesting with our data. We want to pull out some statistics. I actually don't write pandas very often, so if I've committed any cardinal sins, please forgive me. But hopefully it looks mostly how it's meant to look in terms of getting out a row count, maybe looking at the different languages, how many different languages have books been checked out in, and what's the breakdown by sort of the different age categories. Juvenile is the most popular for this across the Brisbane libraries, but interestingly, the adult category is pretty much up there as well. And possibly more interesting, let's look at the PySpark version. So we can see pretty much most of the functions do what they say on the tin. We've got our count at the top, which will tell us our rows in our data frame. We can select and filter down our data frame to get those languages that's distinct. We can do a group by and a count on those age categories. So at this point, it should be at least becoming a little bit obvious that if pandas is Python kind of pretending to be R to some extent, this part of the PySpark library is Python pretending to be SQL, which I quite like. I find that quite intuitive. There's an element of you're able to make some assumptions about what you should be able to do based on your knowledge of SQL, and you can translate that across into Python. Cool. Let's go with one more scenario. So in this case, we're going to try and group any checkouts that occur within 5 seconds of each other in the same library. So I'm going to make this assumption. If it's happening close together in time, then I can say that the same person did it. Now, obviously, you might have different checkout machines in the same library. It's not perfect, but it's going to let us play around with the data a little bit. And we've got another code example. Now, don't worry too much if you can't really read this. This isn't really one that I'm going to go through in a lot of detail. This is more just about proving that I wrote the code. That it is possible. Also, it's a little bit of my love letter to window functions, because I think they're fantastic, and I love using them, and I liked that I got to use them in this example. But I will move on pretty quickly, but feel free if you are curious about this or any other element to come find me afterwards. And I'm also going to be putting a lot of this up on GitHub, so you can find it later. But if we run this, we can find the checkout with the group with the largest amount of checkouts. And we can go have a look at it. And it's this one, which might be a little bit hard to read, but I love this because I get to imagine some kid had just the best 68 seconds of their life as they borrowed out everything ever. There is Wings of Fire, Miles Morales, half of Ando's back catalog. And I mean, really, why would we work with data except to find things like this? My personal favorite, I don't know if you know how fastbacks work, but basically it's a category in the library where you get exactly a week to read that book and you are not allowed to renew it. The degree of optimism I get to imagine that this kid has about their week, I love that so much. Cool. But back to the point of the talk. What should I use? Who doesn't love a benchmark? OK, so luckily I found one someone made before me, so you can go check them out. This evaluation actually happened back in 2021. All of these libraries have changed to some degree since then, so this is really just meant to be a very look, they're all relatively similar on small data sets. But if we go to a larger data set, and this is an important point of one of the reasons you might be interested in learning more about PySpark might have less to do with your innate interest in learning about a new topic, and it might be that your current tools have stopped working for your data set because it got too big. So that's kind of a big selling point. And maybe you're at this point, you're OK, fair enough. I'm curious. I want to learn a bit more. Let's go have a look under the hood. And this is the count function. And we see that when we call the count function on a data frame, it immediately calls something else and asks it for the count. And that thing has a little j prefixing it, which is making us think maybe under the hood there's something happening that's not totally Pythonic. And we go to a collect. And a collect is where we say, hey, I want this data frame as a list of records. A list is, that's very, that is in Python. This has to be far more Python. This will be great. Yes, who doesn't love seeing sockets and pickling in their Python library? Yeah. So I'm told it works, and a lot of smarter people than me have worked on this, and I believe it works, and I try not to think too hard about this exact moment when data is being thrown back and forth in the worst game of catch ever. But yeah, as far as I'm aware, it works. We get the data out in Python. It does appear to be that Java is entirely hiding under my library. Slightly concerning. And at this point, I have to come clean and say that I have actually come to a Python conference ostensibly to talk about a Python library that is just the smallest amount of Python wrapped around a Scala library. So I'm sorry. But you can, for the most part, pretend the Scala doesn't exist, except when it throws errors that are massive Java stack traces, which is slightly ominous from your Python code. I like this image because it's just the star on the end with the tiny little bit of Python wrapped around it, because I think it is very illustrative of what is going on in this library. But this does raise the obvious question. why? Why do we need a massive thing of Scala underneath our Python code? Why? What could possibly it be offering me that would justify this? And it's because Spark is basically, what if we had functional programming on data and we distributed it? And wouldn't that be great and fine, and it would never cause any problems for anyone, and it's fantastic. Cool. So, distribution. Now, important to touch on at this point in the presentation, all of the code examples, everything I've been kind of talking to up to this point, that's the driver program. We can see that lovely Spark context. Got it dodged a little bit earlier. In terms of if you just want to get started, you just want to have a play around, you're not too concerned about sort of dealing with that out of memory, like really running a massive data set, you can kind of get to this point and just have a play around. You don't need to worry about the next part yet. You can do a pip install, maybe play around with a couple of Java settings, but you can open up a notebook and be running pretty quickly and on your sort of smaller library checkouts data set. But let's say you are interested in this idea of, I want to throw some worker nodes at my problem. I want to really have the benefit of being able to work with that larger data set and not spend 3 days waiting for my code to run. And great, we're going to stick a cluster manager in the middle. So we have our lively diagram. And it's going to look something like this in terms of a dashboard. This one's pretty empty, but it's just there for illustration. And basically, the promise PySpark is making to us is, if you write this Java program and you write all the code using the library that you've been given, it will handle all of the thinking about how we decide what data goes on which node and which node is doing which task and how the processing is going to happen. And whether you believe the library is entirely up to you. But I will admit it does make life a lot easier sometimes. But if you don't totally believe the library when it says, hey, you don't never need to worry about it, we might want to know a little bit more about what's happening under the hood. And to understand that, we have to go back to MapReduce, which is the thing that came before Spark. And so I'm going to move through this very, very quickly, but it's just a kind of a nice background. MapReduce, start with some input data, splits the input data across the different nodes, applies a map to it, shuffles the data across the different nodes, applies a reduce to it, and outputs. It's lovely, it does exactly what it says on the tin, makes it very simple and easy to remember. Super useful in the sense that it solves a problem around how do we split out the data and with our processing. Downsides are that if you want to do more complex things, you have to start stringing a lot of these together. Those shuffling steps are going to take a while. The input and output steps are going to start to come for you after a while. So eventually you are going to really see some issues with the runtime of your programs. But we all promised Spark was going to do it better. So what does Spark do differently? So Spark takes this idea of things like the map and the reduce, so those transformations, and says, what if they were lazy? So we can just, as we're building them all up, we can build this lovely, big, beautiful evaluation plan of all the different transformations we're going to want to do. And then, so it's going to be a lovely, big, directed acyclic graph. And then we can start to lay it out, and we can start to optimize across that. So we can break it out into stages. A stage is any kind of processing we can do before we have to shuffle the data. So maybe we've got the parallelize, the filter, the map. They can all happen with the layout of the data across one node. And it's sort of moving this around and reorganizing this under the hood. I think of it a little bit like the relationship of SQL to relational algebra. I don't know if that's a totally accurate sort of parallel, but it's useful for me in my head. So maybe we've got this. We've got a stage 2 where, because we're going to do a reduce by key, we need to shuffle the data relative to the key that we're reducing on. Maybe we have to shuffle again for our stage 3 because we're going to do a join. We're joining on some different fields potentially. Yeah, we have this lovely optimized graph that PySpark is producing for us. There is one thing that might come up. Again, depends how sooner or later whether you will hit this. You might get an out of memory error at some point. And that's going to be really annoying because you're going to be like, hey, I just started using this library because it promised it would solve all of my memory issues and I would never have to worry about that ever again. And yes, the problem is that this out of memory issue is actually that the plan got too big. And so you either need to simplify the plan or allocate more memory in config. It's a very easy fix. There's a bunch of Stack Overflow questions and answers about it. It's just a really weird thing to look up, so I like to flag it early before you spend half a day trying to figure out what just went wrong and why your program is complaining at you. Cool. So we've got our lovely transformations, we've got all those stages of processing, but they're all lazy. So at some point, we're going to have to throw some actions into the mix, which is when we actually want the result. So these are going to be eager, they're going to force the evaluation of the plan. And you might be sitting there thinking, great, I got you. I'm going to have my lovely plan, I'm going to do my stages 1, 2, 3 of processing, and then I'm going to do my first action, which is going to be a count, because I want to know how many rows of data my output's going to have. I'm going to have my show, because I want to have a couple of examples of what my output looks like. And then I'm going to save out, save as table, save as CSV, whatever I'm going to do. And that's, yes, but your processing might end up looking more like this. Because for all of the optimization that's going to happen on the transformation side, Spark is going to be really eager as soon as it hits an action. So it's going to do all the processing when you ask it for a count, and it'll give you that count result. And then it will potentially do all of that processing again and show your results. And then it'll do all of that processing a third time, and then it'll save out the data. So if your programs are running really slow, you're feeling like they're running maybe 3 to 4 times longer than they probably should take, this might be what's happening. So again, in terms of introductory stuff, I'm not going to sort of go hugely in-depth into memory management, but it's worth flagging that it's something that you will need to think about sort of sooner or later, and the sooner is going to be when stuff starts taking way longer than you're thinking, but when you think it should. But definitely, you need to be thinking about this to avoid that sort of multiple levels of processing across the stages. Sweet. As an example, I found this Stack Overflow question. I love it because someone basically has asked, hey, I put some checkpoints in, and I have all these skip stages, and is that helping my performance? And the answer is yes. So we can we can break this down and we can see the concepts we've been talking about up to this point. So each row is an action that has happened. It might be a little bit hard to see, but we can see in that second from the right column, the different stages of processing, and especially near that top, they've got sort of 7 stages of processing happening, but they've got 11 skipped. And that's because they're holding the data that's been processed up to that point in memory. So they've told Spark, like, hey, I want you to reuse this bit, don't forget about it the second it's gone. And right in the far, we've got the tasks, which is the count of like the individual tasks that are happening across all of the worker nodes, across all of the stages. So that number tends to be pretty big. Cool. So in terms of what I want to cover, oh yeah, there was going to be a whole version of this where I just ranted about Java stack traces in my Python program for ages, but full credit to the people working on PySpark is that the error messages have gotten substantially better over the last few years, so there is substantially less ranting from me on that front, so shout out to them. In terms of otherwise, because we have the actions of being lazy and then the eager evaluation. Depending on the complexity of your error, it's pretty likely that an error in your plan is going to happen or be thrown at the point of evaluation. So at that count, at that show, but it could be quite higher up a fair bit higher up in the plan, and so it is worth looking at. Not too scary, but just I have had colleagues who haven't necessarily had a heap of programming experience come in from SQL, and they've been doing a really good job of like figuring out where the error was happening and trying to put in statements around it and trying to explore it, and just not realizing that it was substantially higher up because of the way the lazy and eager interacted with each other. The other fun gotcha is because our code is going to look more like the thing on the left in terms of, we've written out the stages of the transformations that we want and then the actions. But the processing is potentially with that duplication is if you have non-deterministic data coming through. So for example, if you are grabbing 1,000 rows from your table and you don't really care which 1,000 rows you grab at the start, you could potentially end up in a situation where the rows that are fed into that show are different to the rows that are fed into that save. And again, memory management is going to potentially save you there in terms of saying, no, I want to save the processing at this point and use it from there. That most confusingly comes up when you start joining a data frame to itself and you aren't getting any results from the join, because each side of that data frame is taking its own source data. So that can be a bit of an odd one to track down again. And if you throw shows in, they'll get different results as well. Cool. The other way to handle that is to just put like an order by or be more selective in terms of how if you are doing a subset of data. Cool. So, what should I use? This is going to depend really heavily on you, and I unfortunately can't recommend one way or the other. There are a bunch of tools out there, but things you might want to consider: how much data do you have? What does your current code base look like? In my current job, we work with a lot of geospatial data. PySpark doesn't have good geospatial capability. There is Apache Sedona, which just came out of incubation in, I think, March of this year. If anyone here knows anything about it, please come and find me. I am very, very curious to learn more about what is going on in that space. Other questions? How much time do you want to spend on infrastructure? That can also be substituted for how much money, how much headaches, what's the capability of the people in your team? Do you want to ask someone else buy a different product? I'm sure there are people at this conference who would probably very willingly sell you some stuff. Who is working on your code, and any personal preferences. I actually just really like using PySpark as just like noodling around on my laptop. For small projects, I find it a little bit more intuitive than Pandas, but that's going to be a total personal preference thing. In conclusion, what is PySpark? Oh, yep. Hopefully I've answered that at least a little bit. Can it solve all of my data problems? Kind of, but you also get some really fun new ones. And are you sure I can't just use pandas instead? So they did a bit of a bait and switch here. They did actually bring out a pandas API a while back. I haven't personally used it, so I can't give you any advice on how well it works, but it is there. So if you don't like the look of the code I've been showing you, there is a whole other section of the library that you can definitely check out and have a look at. Cool. And then the one other thing I wanted to cover, sweet. So if you have sat through to this far and you're like, yep, that's pretty good, that's pretty informative, but Alex, like, I really want to know more about this, and I really want to know from someone who actually like really knows what they're talking about, I highly recommend checking out Holden Corral. She actually gave a presentation on PySpark at PyCon Australia back in 2017, so that's on YouTube. But she's given a bunch of presentations about PySpark. I watched many of them when preparing for this talk, so I'm definitely very grateful for that. She's written a bunch of books on Spark, so if you have an employer that enjoys buying textbooks, that's worth checking out. But yeah, otherwise, I think that's everything. Sweet. I totally lost track of time on that one.
No, that was great. Thank you so much for that talk. I think the problem of what I've run out of memory for analyzing my data and what to do is a perennial one, which I think it's always good to have some good guidance on what to do. And that was a really good, practically sort of demystifying PySpark. So thank you so much. And I'm going to just forgotten my. Gift we have here for you.
Thank you.
Thank you very much. If you have questions for Alex, please pop them in the Discord or come and chat to Alex later on. And so with that, can we have a big round of applause?